Today, I'm going to be introducing some research using historical maps that has come out of the Living with Machines Digital History Project. It's based at the Alan Turing Institute in the British Library. This work involves a lot of people, and especially my colleagues named here, Kazra Hosseini, Daniel Wilson, and Casper Beelan. I'm Katie McDonough. What you see here is a typically collaborative Living with Machines endeavor. And last, just before I dive in, our thanks go to the National Library of Scotland, who made their maps and map metadata available to us and have been wonderful collaborators. As a research project, Living with Machines seeks to find new ways to understand the impact of industrialization on British lives in the long 19th century. So in addition to working with newspapers and census records, very early on, we turned to one of the major cartographic productions of the 19th century, Ordnance Survey maps scanned by the National Library of Scotland. OS maps were the first maps to be scientifically surveyed and printed with coverage of England, Wales, and Scotland. As you can see in the detail of a late 19th century sheet of Cardiff here, these large-scale maps provide unparalleled access to information about the ways that the physical manifestation of industrialization, factories, mills, railways, and more, transformed communities. Maps are often used as illustrations in support of an argument being made principally with information from textual sources, or data, as we might say at the Turing. But there are so many maps that were produced, especially since the 18th century, that Living with Machines really saw an opportunity to figure out how to work with these very large collections of digitized maps using computational methods. In doing so, we saw an opportunity not only to normalize the use of maps as data in the humanities, we also wanted to write new arguments about the impact of industrialization, and specifically the arrival of rail across the entire island. So this ability to work at a large scale and with very high resolution information is really unheard of for scholarship about the 19th century. To ask questions of thousands of maps at once and to generate data sets that allow us to classify the landscape according to the concepts at the heart of those questions, we developed a computer vision pipeline called MapReader. MapReader allows us to work with the visual information on maps at the level of patches, which you see in the detail of one sheet here in the bottom image of panel C. For our first experiment, we trained and applied a MapReader model to about 15,000 19th century OS map sheets. This task classified about 30.5 million patches as rail or not rail. The example patches you see here are black for predictions of rail by the MapReader model. And collected manually, it would have taken thousands of hours to digitize these features. And we can also zoom out and look at the distribution of railway patches in England, Wales, and Scotland, as shown in panel B. So using MapReader to quickly and flexibly learn about the presence and absence of, in this case, rail, but potentially anything that has a visual representation on the map sheet, really transform what it's possible to ask questions about in historical landscapes. If you want to know more about MapReader and our case studies focusing on British railway infrastructure as well as buildings on 19th century OS maps, we have a preprint on Archive, see the link just here at the bottom of the slide. MapReader has been released openly on GitHub, and our patch level data sets will also be released openly shortly. And finally, we're excited that there are already new applications for MapReader happening here at the Turing. So please have a look at the demo from the SciVision team, who will be sharing an early results using MapReader and its patchwork method for a plant phenotyping project. We look forward to hearing from anyone with an interest in using MapReader. Thank you.